There is a specific kind of shock that hits American visitors when they land in certain Chinese cities for the first time. Not the kind that comes from something being foreign or unfamiliar. The kind that comes from realizing that the city you just stepped into is operating at a level of technological integration, physical infrastructure, and urban efficiency that makes the city you flew in from feel like it belongs to a different era entirely. Not a different culture, a different century. This is not about futuristic aesthetics or impressive skylines, though both are present in abundance. It is about systems, the way a city actually functions at the level of daily life, how people move, pay, communicate, and interact with the physical environment around them. When those systems work seamlessly, invisibly, and at a scale of tens of millions of people simultaneously, the cumulative effect is something that photographs cannot capture. You have to be standing in it to fully understand what has been built. America has world-class cities. It has extraordinary concentrations of talent, capital, and innovation. But it also has infrastructure that in many places has not been fundamentally upgraded since the mid-20th century. Bridges built in the 1960s, subway systems running on signaling technology from the 1930s, payment systems that still rely on physical cards in contexts where Chinese cities moved to facial recognition payments half a decade ago. The gap is not explainable by money alone. It is a gap in vision, in planning, and in the willingness to build at a scale and speed that American systems have largely lost the ability to match. These are 10 Chinese megacities already living in a version of the future the rest of the world is still trying to reach. In 1980, Shenzhen was a fishing village of roughly 30,000 people. Today, it is a megacity of over 17 million, home to some of the most consequential technology companies on Earth, and operating urban systems so advanced that delegations from cities worldwide fly in specifically to study how it works. Shenzhen's streets are dominated by electric vehicles to a degree no other major city has matched. Its bus fleet went fully electric years before any comparable Western city managed even a significant partial transition. Its metro system runs with punctuality and passenger capacity that makes the New York subway look like a historical artifact. But the infrastructure is almost secondary to the ecosystem it enabled. Huawei, Tencent, and DJI are all headquartered here. The density of electronics manufacturing, component supply chains, and hardware engineering talent means a hardware startup in Shenzhen can go from concept to physical prototype in days, rather than the weeks the same process takes in Silicon Valley. The city also operates one of the most sophisticated urban sensor networks in the world, with cameras and data infrastructure woven into the physical environment at a density that gives city managers real-time visibility across the entire metropolitan area simultaneously. Shenzhen did not retrofit this technology onto an existing city. It built the city and the technology together, which is why they fit so seamlessly. The maglev train connecting Shanghai Pudong Airport to the city center covers 30 kilometers in just over 7 minutes at 430 kilometers per hour. It has been doing this since 2004. In the 2 decades since that line opened, most Western cities have been having lengthy public debates about whether to study the feasibility of high-speed rail. Shanghai built one and ran it for 20 years, but the maglev is almost a footnote compared to what Shanghai has built since. Cashless payment penetration is essentially total in commercial settings. The integrated transit app Shanghai residents use does not just show metro times. It integrates real-time road conditions, shared bicycle availability, electric scooter networks, ferry schedules, and ride-hailing into a single interface that optimizes your complete journey across every available mode simultaneously. The system knows where you are, knows the nearest available bike, knows your usual route has a delay, and has already recalculated before you finish reading the notification. Shanghai's port is the busiest container port in the world. The automation level in its newest terminals, with autonomous cranes, and AI-driven logistics optimization managing the entire flow, represents a model that port operators globally are trying to understand and replicate. The city does not just look like the future, it runs like it. Beijing manages 22 million people across terrain ranging from dense urban core to satellite cities connected by high-speed rail. Doing that requires infrastructure at a level of sophistication Beijing has built systematically over 2 decades. The city's facial recognition infrastructure is the most extensive of any city on Earth, and the civil liberties concerns it raises are legitimate and serious. Both things can be true simultaneously. The system works with extraordinary effectiveness as an urban management tool, and it raises fundamental questions about state power that are not resolved by pointing to operational efficiency. What is less contested is what the underlying data infrastructure enables for services. Traffic management uses real-time data from cameras, sensors, and connected devices to optimize signal timing with a responsiveness that static systems cannot approach. Emergency services routing uses the same infrastructure to reduce response times in ways that have measurable effects on outcomes. Beijing subway has expanded from 114 kilometers of track in 2002 to over 800 kilometers today. It moves more passengers daily than the entire U.S. urban rail system combined. The stations run platform screen doors, real-time crowd management, and ticketing infrastructure integrated seamlessly with mobile payment platforms. The scale alone is staggering. The efficiency behind it is what keeps foreign urban planners coming back. Chengdu does not usually appear at the top of lists about technological megacities, which is exactly why it belongs here. While attention focuses on coastal giants, Chengdu has been building something that represents a different dimension of urban innovation entirely. One focused on integrating natural systems into dense urban environments in ways that address the fundamental livability challenges every megacity eventually faces. The Tianfu Greenway project has woven over 1,000 kilometers of connected green corridors through the metropolitan area, linking parks, wetlands, agricultural land, and neighborhoods into a continuous network that functions simultaneously as recreation space, biodiversity habitat, urban heat management infrastructure, and flood control system. This is not decorative landscaping, it is engineered ecology, designed by teams including hydrologists, climate scientists, and ecologists, using data modeling to optimize natural features for maximum functional benefit to the city around them. The Tianfu New Area was designed from the ground up around integrating technology and nature, rather than treating them as competing priorities. Underground utility corridors eliminate street excavation for maintenance. Buildings generate portions of their own energy. Water management captures and recycles rainfall at the district level. Chengdu proves that the future of cities does not have to mean replacing nature. It can mean designing with it. Hangzhou is where Alibaba was founded, and the city has functioned as the real-world laboratory for the technologies Alibaba built. Digital payments, smart retail, AI urban management, and e-commerce logistics have all been tested and refined here at a scale no other city has experienced. The Hangzhou City Brain is the most ambitious urban AI management system ever actually deployed at city scale. It integrates data from cameras, sensors, and connected devices across the entire city into a central system, managing traffic signals, emergency dispatch, infrastructure monitoring, and city operations in real time. When an ambulance needs to cross the city, City Brain automatically clears a path through the signal system ahead of it, reducing average emergency response times by measurable minutes. When a traffic incident occurs, it is detected, classified, and addressed in seconds, rather than the minutes human-dependent monitoring requires. Cashless payment reached levels that effectively made physical cash optional in daily commercial life years before comparable transitions were seriously discussed in most Western cities. Not just retail. Utility bills, government services, medical appointments, transportation, parking, and food delivery all run through the same integrated digital infrastructure. The logistics network surrounding Hangzhou, built around Alibaba's e-commerce volumes, processes and ships orders in time frames that Western logistics operators benchmark as the current frontier of what is physically possible. Guangzhou built its economy on manufacturing and is now going through a transition as significant as its original industrialization. The city that supplied the world with consumer goods is systematically rebuilding itself around automation, artificial intelligence, and advanced manufacturing, converting a labor cost advantage into a technology advantage as the competitive logic has shifted. The Nansha district has become one of the most concentrated locations of autonomous vehicle deployment anywhere in the world. Baidu's Apollo platform operates robotaxi services in Nansha that have accumulated more real passenger miles in genuine urban conditions than comparable services in any American city. This is not a closed test course. It is a real district with real traffic, real pedestrians, and the full complexity of a functioning urban neighborhood operating around it. The port, fifth busiest in the world, has integrated automation at a pace that reflects the broader transition underway. Automated container handling, AI logistics coordination, and digital customs processing have reduced cargo clearance times in ways that compound into enormous economic advantages across a full year of trade volume. The industrial zones, once running on assembly labor, now run on collaborative robot systems, with the ratio shifting consistently as the economics of automation improve at every skill level. Wuhan carries the weight of being the city where COVID-19 first emerged. What gets less attention is what the city built during its recovery. The reconstruction that followed was not simply a return to the previous state. It was a rebuilding that incorporated technologies and urban systems at a scale and speed that the crisis, paradoxically, created the political conditions to make possible. Cities rarely get the opportunity to upgrade their urban systems all at once. Normal urban life creates inertia that makes large-scale transformation slow and difficult. Wuhan's extraordinary circumstances created an unusual window, and the city used it. Public health monitoring infrastructure, crowd density sensing, integrated health data systems, and digital service platforms were deployed at a pace impossible under normal conditions. The air quality monitoring network now operates at a density that gives city managers granular data identifying pollution sources at the neighborhood level. Wuhan's position as a major inland transportation hub has been enhanced by high-speed rail connections, making it reachable from Shanghai in under 5 hours and from Beijing in competitive times. That connectivity has pulled Wuhan into the orbit of coastal economic dynamism in ways that previous infrastructure generations made structurally impossible, fundamentally changing the economic geography of central China in the process. Chongqing presents a geographical challenge that should, by conventional planning logic, have made large-scale urban development impossible. It sits at the confluence of two rivers, surrounded by mountains, built across terrain so dramatic that the concept of a flat city grid simply does not apply. Streets run at steep angles. Buildings are constructed into hillsides. Elevation changes of hundreds of meters occur within walking distance. Rather than fighting the terrain, Chongqing built around it. Its metro system, navigating mountains and rivers with underground tunnels, elevated viaducts, and in one famous case, a train passing directly through the middle of a residential building between the 6th and 8th floors, has somehow become one of the most extensive urban rail networks in the world. The engineering solutions required to achieve this represent a concentration of civil engineering expertise now being applied to infrastructure challenges across China and in overseas projects. The city of over 30 million people has built digital infrastructure across terrain that challenged every standard approach. The connectivity solutions developed for Chongqing's unique geography have produced innovations in wireless network architecture and multi-level urban design that planners worldwide study as solutions to problems that more conventionally situated cities will inevitably face as they grow denser and more complex. Tianjin has spent decades operating in Beijing's shadow, which gave it the freedom to experiment with urban and industrial systems that higher-profile cities might have been more conservative about. The results are making Tianjin one of the most watched cities in the world among energy transition researchers. The city has committed to hydrogen as a central energy transition pillar at a scale that goes well beyond demonstration projects. Hydrogen fuel cell buses operate across multiple city routes. Hydrogen-powered logistics vehicles move cargo through the port district. Hydrogen production facilities are operating at commercial scale. The infrastructure connecting production to distribution to end use is more developed here than in virtually any other comparable city anywhere in the world. The port, the largest in northern China, has been integrating automation and digital management at a pace reflecting the broader industrial transformation underway across the metropolitan economy. Tianjin's Binhai New Area, built around smart city design principles, incorporates energy efficiency, digital infrastructure, and transportation integration from the ground up, demonstrating what urban development looks like when technology is a design input rather than a retrofit added later. Xiong'an does not yet appear on most megacity lists because by population, it is not yet one. It belongs here because it represents the most ambitious urban construction project currently underway on Earth, and because what is being built there is the clearest statement China has made about what a city should look like at the middle of the 21st century. Announced in 2017 and being built essentially from nothing on previously agricultural land, Xiong'an is designed to eventually house several million people, built to specifications that assume the technology of 2040 rather than today. Underground utility tunnels wide enough to drive maintenance vehicles through run beneath every street, eliminating road excavation for repairs permanently. The entire city is designed around public transportation and pedestrian movement, with private vehicle access restricted in ways that make car ownership economically irrational for most residents. Autonomous vehicle infrastructure is embedded in the road design. Fiber optic and 6G antenna infrastructure is built into every building from construction. The most radical element is the underground logistics network. Autonomous delivery vehicles operating in underground tunnels will handle all goods movement throughout the city entirely below street level, removing delivery vehicles from surface streets completely and solving one of the most persistent and seemingly unsolvable problems of dense urban environments. No other city has attempted this at scale. Xiong'an is not running a pilot. It is building it as the city's permanent infrastructure from day one. Stand in Xiong'an's rising urban core, or on Shenzhen's electric bus network, or watching City Brain manage Hangzhou's traffic in real time. And the question that keeps surfacing is not how China built these things. The question is what it means that they exist at this scale, with this consistency, across this many cities simultaneously. America has extraordinary cities. It has talent, capital, and innovation that remains globally formidable. But it also has a system that has become very skilled at explaining why transformative infrastructure cannot be built quickly, why new technologies cannot be deployed at scale before every objection is fully resolved, and why the gap between what is technically possible and what actually gets built should be accepted as a natural feature of democratic complexity. China's megacities are a direct challenge to that acceptance. Not because the political system that built them is worth emulating. It is not. But because the physical results of building with speed and at scale are visible, functional, and increasingly impossible to explain away. The future being lived in these 10 cities was not inevitable. It was chosen, planned, funded, and built. And the question of how democracies match that pace has become considerably more urgent now that the world can see exactly what falling behind actually looks like on the ground. The future arrived in China's megacities. The rest of the world is still figuring out how to book the flight.